Hello everyone and welcome back to another video. Today we're going to overlook the configuration of LACP on an Ubuntu deployment. And this is something that can be done in conjunction with the previous video, meaning that both of these can be done at the same time, where you are setting up both LACP for your Ubuntu deployment before you start your cloud deployment, and you can you can configure your multiple drive configuration, whether it's going to be software RAID 0, software RAID 5, software RAID 6, or whatever for high availability purposes, such as fault tolerance. But to keep it simple, what we're going to do today is we're going to do the network configuration part of it. So I have set up a virtual machine, as you can see, with a very simple, where is it? It's a very simple hard disk of 64 gigabytes and with 4 networking adapters that we're going to use to configure LACP. So why am I choosing LACP as a networking solution for the cloud server? Because LACP works in a very interesting fashion, for me anyways, and I find that very intriguing. On one end, because it does provide, theoretically speaking, okay, in practice, I'm going to explain it in a different manner, but in theory, what it does is it provides a widening of the bandwidth that you have available for your server, and it also provides fault tolerance 2-in-1, which can be much better handled whenever you are working in, I would like to say, in a complicated environment, just like you would be when you are standing up a cloud server or a cloud cluster. So in practice, how does it work? In practice, while theoretically, yes, you do get bandwidth widening, it's not a total of all the network interfaces put together. What I mean by that is, if you have 4 single gig NICs, okay, I'm gonna give you guys a solid example. If you have 4 single gig NICs, okay, and you LACP them together, theoretically speaking, yes, you do get 4 gigabits per second total bandwidth. However, you still are limited by the per interface 1 gigabit limit. Now, if you were to do 2.5 gig or 10 gig, that would still be valid for those NICs. However, that is only valid when you have a single connection. So, for example, host to host, when you have a single connection, it's only going to be limited by that 1 gigabit per second. And you are going to notice that whenever you're transferring a large file from host A to host B. Now, whenever you're, for example, torrenting a file from Microsoft servers, the official one, okay, you are going to observe a theoretical limit of 4, well, it's 4 minus a little bit of overhead, but theoretically 4 gigabits per second, because in this scenario, you are observing multiple connections. So this is where your kind of like parallel operation comes into play, and it is fantastic for when you're creating something like whether it's going to be a content delivery network, a cloud operation, or just anything that could take advantage of the multi-connection, multi-session, so that it can actually take advantage of the LACP bandwidth enlargement. And this is what we're going to be setting up today. Now, this has to get done on both ends. So if you have a layer 3 switch, this is something that we're going to be observing in the next video. But for the purpose of this video, we're only going to be observing the network setup on the host side. So what I have done so far is I have booted the Ubuntu standard ISO, and it's version 22.04.05, whatever is the long-term support from the 22 version. And we're just going to, you know what, why not? Let's update to the latest version of the installer. As you can see, 22.04.5 correction. So let's go ahead and so here we are at our network interfaces. So let's go ahead and create a bond. We are going to select all of them, and under bond mode, we are going to select 802.3AD. And in the transmit hash policy, you always want to select the highest one available. So we're not going to be doing encapsulation 3+4, we're going to be doing layer 3+4. Encapsulation, there's a different play. I'm still trying to make out what the documents are under Linux encapsulation 3+4 versus Linux layer 3+4. But there is a very significant difference that, especially when you're working in switches, with layer 3 switches, and you have LACP on that one as well, it's a very prominent difference that ideally you would want to better understand it, or in my case, I would like to better explain it to you before you go ahead and apply it. So for the purpose of this video, keeping it simple, let's just go ahead and select layer 3 and 4. Now, once that is selected, LACP rates, I think it's 1 minute for the slow rate, or sorry, yeah, 1 minute for the slow rate, and no, that can't be right. Hold on. LACP rate slow. Okay, so 30 seconds. And then the fast rate is between 1 and 3 seconds. Yeah, 3 seconds. Okay, sorry about that. So the fast rate is 3 seconds, the slow rate is 3 seconds. If you are comfortable with your environment, and please put an asterisk on this, because this is something that I will come back into the next video when I'm talking about the switch configuration and everything. The difference is there. However, it does create a little bit more traffic overhead, but because of the way we're going to be configuring our switches, or sorry, the way that I'm going to demonstrate the switch configuration, for this purpose, we're only going to be using the slow rate. So let's go ahead and click on create. And as you can see, now we have a new virtual interface called bond 0. However, it is disabled. Now, we're going to click on edit IPv4, and under the method where it says disabled, for demonstrative purposes only, we're going to put it on automatic in DHCP. However, you can put it in on manual and enter your details by yourself. But like I said, for demonstrative purposes, we're going to leave it as DHCP. I don't think it will grab an address, because I have not finished. Oh, hey, it did. Okay, fantastic. Never mind that. But yeah, I have not fully finished configuring the LACP trunk on the switch yet, so I didn't think it would grab it, but hey, it grabbed it, so whatever. So once you have verified your settings and you are happy with all of this, you can go ahead and click on done. In a more advanced environment, you can also create you can also add a VLAN tag, which what's going to happen once you input the VLAN ID, like for example, I don't know, just for all intents and purposes, 100. What that's going to do is it's going to disable or remove the DHCP ability on the primary logical interface, and then it will create a logical interface on top of that logical interface, and it's going to use that as a parent. But because, like I said, in our case, we're keeping it simple, we're not going to overcomplicate things too much. We're just going to keep it with simple. So as soon as it grabs another IPv4 address, we are going to continue. Oh, come on, it's okay. And then it will take a minute, and for the configuration to take into effect. But essentially, as soon as it grabs the IP from DHCP, if you're running with static leases, or you can confirm network connectivity via your static details, your LACP is finished. And for all intents and purposes, the networking portion on the host side will be completed. So go ahead and just click on done, and go through the rest of the setup process. That being said, thank you so very much for joining me for this quick and dirty LACP setup on Ubuntu Server. We are going to continue, and like I said, we're not going to worry about VLANs just yet. They are going to come a little bit further in the tutorial aspect of this video, so do not worry about it. We are going to be configuring an LACP trunk on a layer 3 switch in the next video. Please be patient. Continue supporting the channel, subscribe, comment, like. Everything that you do helps me grow in any way, shape, or form. So I do thank you very much, everybody, for that. I will see you all in the next one.